Okay, differentiation and integration. So what is differentiation? What is integration? Why we need integrate? Why we need differentiate?
We need to materialize
From the
y x thing. You change x power of 3 to x power 2.
okay. So why we need differentiation? Why we need integration? Why we need differentiation? Is it very important or nothing much affected?
Like scale.
Scale.
Yeah, you want to make you first make a small scale and then you derive it or integrate it into a bigger model.
Skill. Maybe. But in your life, actually, the differentiation and integration will use to make the something is function. It function because differentiation and integration will involve function. So what is function? Function meaning something that we can add, we can minus. If we go to the left, so we can go to the right. If we go to up, we can go to the down. And then the important one is we can measure the rate, measure the rate, and then we can analysis the the sine and cos graph. If you see here, we go to application. We go application first. So in application we have a rate. So now we have a rate. We can measure the displacement, velocity, and acceleration. So for example, in our computer, if you see, we
Kita yang air lah. Nah, jom.
hello, sorry, I'm just log out. Okay. So the screen. Okay, so in our life, by using differentiation and integration, we can know the displacement. What is this displacement? The moving object from the fixed plane. So at the t time, how long it will go, and the velocity, the speed, and the acceleration. So if you go to if you notice that in your computer, okay, your computer, at the right hand side, you have a label of your battery, right? Is it your computer is fully charged, half charged, or need to get power to get energy? Do you have that notification at the right hand side? Hello.
Yes.
Yeah.
The
So
computer have like a percentage that us.
yeah. So how they can measure? this percentage, the food, the what, how they can measure by using the function lah, the differentiation and integration function. So that by using that function, so we can this computer can notice this computer have a full battery or half battery or need a supply power. So they measure by using the function lah, that which is the function which defined by a certain by using they tested the function which is what meet the requirement of the computer, something like that lah. So that is one of our application lah for differentiation. So that is important to us because for now, so we can use differentiation and integration to measure that kind of thing, which is relate to the rate, right? The rate which is relate to the time and rate. Okay, and then related time, and then we have, so if we have area, we have volume, how we can relate the volume to the time. Area, volume, still volume, and Pythagoras triangle. Okay, and then we have minimum and maximum point value. So minimum and maximum value will we need the minimum and maximum value. We can measure the minimum, what is the minimum value, and the maximum value for that function. Once we define the function, so we can know the minimum and maximum value. That is, and then we also can know the optimum condition for that function lah, to make it more convenient to use. That is but it's more to the more like mathematical construction lah. So that is the theory lah. So mathematics will give the theory, and then they will apply this to the device and so on. And then we have point of inflection. So we can find the point of inflection. But point of inflection we not cover later. So it's just for your extra knowledge lah. Area. So from integration, we can know the area under the curve, area between the axis, and so on lah. So we can define, we can calculate the area. If before the integration, how to measure the area. To measure the area, we put a square, a square shape, right? We divide this. Before this, to find the area, we divide this, and make this square. So, and then we count the square, how many square, and then this part will be maybe 0.1 or and so on lah, or 0.5. So we define that like that. So there is, if by using integration, so we get no need to use this, but we get a very accurate value of area that cover under the with this graph lah. So there is a few techniques here to find the area under the graph. We have area under the graph, we have area under the axis, and so on lah. We can calculate lah. The idea is we can calculate by using differentiation and integration function. It's more easier lah. So once we can get that, that's why if we construct the program to find the area, so more easier instead of we need to define for each to count every square here. So anything else? I think we can get the volume of the shape, and then a lot of information, a lot of application we can get from differentiation and integration. So differentiation meaning the function will what? The function will reduce. If we have 3x to the power of 3, so the function will reduce to the x to the power of 2. So the notification for the differentiation, we can use this f prime dy dx, y prime dx fx, and capital Dx d bracket d. So as usual, we have a few things we need to know, but you need to know we only have addition, subtraction, multiplication, and division. That is the operation for the mathematics. So only 4. But we need to know the power rules. So what is the power rules? The power rules is if the function is power, if the power if we have a power rules, so we have x to power of n and x to the power of n minus 1. So for example here, so we will have if we have x to the power of 11, negative 11, so dx x to the power of negative 11, so we will have n. 11 is n is negative 11, so we just put n in front, and then x negative 11 minus 1, so we'll have negative 11 x negative 12. Okay, so we have this. And then we have, after we have power rule, we have derivative of constant times a function. So we have a constant, any numbers, and times a function. So if we have this, so what is the constant here? So the constant here is 1 over 5. And then function is x to the power of negative 2. So how to deal with this? How to differentiate this? So we dx, so 1 over 5 is in front, and then we just deal with x to the power of negative 2. So 1 over 5, and then we copy the negative 2, just copy because n here is negative 2, and then we have x negative 2 minus 1. So what we'll have, we will simplify this, so negative 2 over 5 x negative 3, or we can have negative 2 over 5 x to the power of 3 at the denominator. We can put like this. Alright, so next we have differentiation of sum and difference rules. So if we add here, we can separately the function. If we have a separate function, we can easily do the differentiation by separate differentiation with this function and this function, or we just add first and then we we do the differentiation. So it can be both. Okay, so which one will be easier? So that one we can deal with. So okay, for this example 4.3 we have x 6x cubed plus square root x over 5. So make it easier to us to deal with. So we make the square root become 1 over 2. So we have 6x to the power of 3 plus x 1 over 2 over 5. So we differentiate separately. So we will have 6x and then sorry. Okay, we have 6 and then we have 3 and then we have x 3 minus 1 and plus 1 over 5. Okay, and then 1 over 2 we put in front. 1 over 2 I just copy, and 1 over 2 minus 1, and then we simplify. We have 18 x 2 plus 1 over 10 x negative 1 over 2. Okay, so negative 1 over 2, it will be square root. So we know that there is x square. So we have plus what, square root of x negative 1. Okay, we factor out x half and then we get 10. So that's why it will be 18 x square plus 1 over 10 square root of x. Okay, and then we have derivative of a product product multiplication lah. So if we have two function multiply, and then we can use a product rules. So it's like this: if you have ux, and then you will get v x plus you copy the vx and then multiply with differentiate u prime x. Okay, there is ux, and then you get vx equals to this, right? So for example here, so how to make it more easier? So you separate as a u and v. For example here, we have u. What is u? U and v. So what is u? U is x square minus 5. And then we have v. V is equals to 2x square plus 3. And then u prime x, you get 2x. So this is actually x to the power of 0. So anything x to the power of 0, what do you have? What you will have? X to the power of 0, what you will have? X to the power of... Huh? Undefined?
1.
1. Okay, 1. You will have 1. So here, so if you have constant, so you will get what? 0. 0 here. So 0 here. Because 0 if any constant, so if we have 5, okay, differentiate 5, so we get to the x, so we get 0, so minus 0, and then v prime equals to 4x, 4x plus 0. So we arrange this into this formula. So you have u, okay, copy u, x square minus 5 bracket, and then v prime is 4x plus v. What is v? V is 2x square plus 3, and then u prime equals to 2x. And then simplify. So simplify, we have 4x cubed minus 20x plus 4x square. 4x cubed plus 6x. And then simplify again here. So we will get 8x cubed plus minus 20 plus 6x, so we will get 14x, negative 14x. Okay, so negative 14x. Okay, and then we have derivation of a quotient. If we have a function, we have a quotient, so we need to use this formula. So to simplify this formula, so we will have, if you have u v, so we have equals to, okay, we copy with v prime, u prime minus u, copy u, and v prime divide by v square. Start with v. Okay, so example here, so we'll have, if you have this function, so we define this is u, this is v. So u is x square minus 1, v equals to x power 4 plus 1. So differentiate we get ux, 2x. V prime equals to 4x cubed. So we will have, okay, first is copy v. So we have this v. Copy v, differentiate u, 2x minus x square minus 1, copy u, and then differentiate v, 4x cubed, and over v square. So v square, anything is v, and then u bracket and square. Okay, and so we have this. Okay, after we simplify, so if here we have x to the power of 5, we have 2x to the power of 5. So 2x to the power of 5 minus 4x to the power of 5. So we will get negative 2x to the power of 5. So the rest we just copy paste. Okay. Okay, so now we have differentiation trigonometric function. Actually already cover at your YouTube, right? So the most important you need to know is, if you differentiate sign, we get cos. Or you just remember this only. Cos, we differentiate cos, we got negative sign. Okay, you remember this. Because if you just remember one, you just notice that another one will be beside that. Just contra. Okay, so cos x, differentiate cos x, so you get negative x. Negative sign x. Okay. Okay, for the rest, actually the derivative, is come from these two functions for the rest. We know that tan x equals to, what is tan x? Tan x equals to sin x over cos x. So if you want to differentiate this sin x, cos x, So we need to use u, and this is v. So what is u? U is u prime. What is u prime? U prime is cos x. And then v prime is equals to cos prime is equals to negative sine x. Negative sine x. Okay. So differentiate tan x dx. Okay, so equals to, so we have the formula is we start with v u prime minus u v prime over v square. So v is cos x, u prime is cos x, and then minus u. What is u? U is sine x, and cos v prime is negative sine x over cos x, and then bracket square. So what you get? You will get cos square x plus sine square x over cos square x. So cos square x plus sine square x, so you will get 1. So you get 1 over cos square x, or 1 over cos square x. So 1 over cos square x, that's why we get cosecant square x. If we differentiate times, so we will get secant square x. So the most important is cos x equals to negative sine x. If we differentiate cos x, we get negative sine x. This is the most important. And then this is opposite operation lah. Opposite, and then the rest is the derivative from the cos and sine. Alright. So here, if you can we use the quotient rules. This is quotient rule. So we have v prime u prime minus u v prime, and then v square. Alright, so this is product rule. So if you see, this is product rules. So you will have u, and then you have v. So now your task is only to identify what is u, what is v, so that you can know. You need to use product rules or quotient rules. Alright. If you deal with addition and subtraction, it's just easy lah. We can differentiate separately. Okay, exponential. Exponential also important. So if we differentiate exponential, we will get the same thing. Nothing. What happened here? Okay. If differentiate ex, so we get ex. If we differentiate kx, so we get kx. Ax ln a. Okay, the most important here, which is make you confused, is this. If we differentiate ax, a is a number. For example, we have 5x. So if we differentiate this to the x, you will get a is 5x, and then ln 5. That is the mean. The meaning of this. Okay, one more thing is a lot of thing here. So this one you should know, and then this one, another one. This most important, which is make the question will trick you lah. The question will is more difficult lah to deal. So you need to know ln x equals to 1 over x. If differentiate ln x, we got 1 over x. But if we integrate ln x, you do not get 1 over x. You remember this? If you integrate 1 over x, you will get ln x. Okay? It's quite what? The most trap is like here. A lot of students will make mistake here. They assume if we integrate ln x, we get 1 over x. So actually we didn't get the ln x. We need to partial fraction. Okay, and then properties of ln. So we'll get ln if you have actually there is an index law. Index law we have ln x ln an equals to n ln a. If we have ln ab equals to ln a plus ln b. If we have ln a over b, so equals to ln a minus b. So why we need these properties? Okay class, why we need these properties? Why? Any response? Why we need these properties?
To make our equation easier.
Betul. Right answer. So it depends on the question. If the question is quite difficult to deal, so we use these properties to make easier to us to differentiate. Okay, for example like this. How to differentiate this? Because we only know 4x, we get ln 4x. If we have 5x like this, so we get 5x ln 5, right? So we have cos here, so we need to apply these properties first. So when we apply to these properties, so it is equals to ln, take ln both sides, so we get ln y equals to ln 4 cos x. So we will get hey. Okay. No need to take long. Okay, no need to take long. You just apply these rules. So we will have these rules. First, it's something like this. It should be like this. If we have a fx, okay, a fx, a function, and then differentiate this, we will get okay, first we copy paste a fx, and then f prime x and then ln fx. Ln fx. Okay? Ln fx. So that's all like this. What should we do? Okay. So we have, okay, what is we have 4, okay, so 4 fx. So fx kita we have fx. What is fx? Fx equals to cos x. F prime x equals to negative sine x. So if we differentiate this, so we will get what? We will get what is? So 4 sine, just copy first. Copy cos, or I just put the formula first for fx, and then f prime x, and then ln fx. Ln a, so ln 5. So this is ln, this is a. Okay, I just put the formula first, so not confuse a, and then this is a. This is our formula. Okay, and then here we, okay, so the function is dx, so we have 4 cos x, so equals to, okay, just copy this, so we have 4 cos x, and then f prime x equals to negative sine x, and then we have ln a is 5, so a is 5, a is 4, so a is 4. So we simplify this, so we negative 4 cos x ln 4, and then bracket sine x. Okay. Okay, here just exponent. Exponent is more easier. And then okay, the chain rules. After chain rule we have implicit differentiation, and then parametric differentiation, tangent line, and then integration. Okay, we stop for 10 minutes. So for your attendance, please solve this equation and show the, as usual lah, go to the Padlet. The chain rules. What is the chain rules? The chain rules. The chain rules like a function in a function. So we can apply chain rules. So we have this function, square root of function. Square root is a function. In a square root we have a function. And for this we have a ln, and in ln we have a function as sine x. So we chain rules, we represent this function into, for example, if you represent into u, so y will be square root of u. So it's more easier lah to deal with differentiation. So where u is 7x minus 5. 7x minus 5. Hello, are you here now? You listen?
Yes, doctor.
Okay, I thought I just mumbling and bumbling sorang-sorang. Okay, so now So with this function, it's more easier to deal. So we just y equals to, we not differentiate yet, but we just simplify the function. So now we differentiate this with respect to u. So we will get 1 over 2 u 1 over 2 minus 1. Simplify. 1 over 2 negative 1 over 2. Okay. So this is dy du. So dy du. So now we want to dy dx. So actually to denote this more easier is like this. We use dy du because we differentiate with respect to u. So now this is du dx. No, this is u. Sorry, this is u. So du dx. So we differentiate with respect to x. So we will have 7. So now to get dy dx, So dy dx we have d equals to dy dx equals to dy du. Okay, dy du, and then we have du dx. Multiply du dx. So we get dy dx. So what is dy du? Dy du 1 over 2 u negative 1 over 2 du dx, we got 7. So we will get negative 7 over 2 square root of u, and then we have 7 u. What is u? Square root of u is 7x minus 5, something like this. So that's what we get this. So this is similar to this example. So we define first. What is u here? What is u? Okay, u is sin x. Okay, u is sin x. So now y will be y equals to ln u. So it's more easier to deal. So make sure you select the most easiest the function that after we put u, it become more become more easy to deal. That is important lah, selection of u tu. Right, so we have du dx because we have x here with respect to x, so we got cos x, and then dy is dy du because they have u here, so we will get equals to 1 over u. So now dy over du dx equals to dy du times du dx 1 over x, and 1 over u cos x. So what is u? U is sin x. U is sin 1 over sin x. So we got cos x. So cos x over sin x. So we got tan x equals to sin x over cos x. So we have got 1 over tan x equals to cot x cotangent x equals to cos x over sin x. So this is equals to cotangent x. Okay. So you can try this and this. Okay, so next, implicit differentiation. What is implicit differentiation? The implicit differentiation meaning we have x and y inside. Y also we have what? We have power for before this we just have y, no power for y, but here we have power for y. So what should we do? Implicit. So we know that in y we have x. So for example here, the rules for differentiation is similar, but we just define y because in y we have x. So how to deal it here? So to differentiate this, so we differentiate as usual. So we have 25 x square minus 1, and then we differentiate the plus 2y, okay, 2y, 2 minus 1, because in y we have x, so dy dx we put here at the back, in front also can. So we differentiate the constant, we get 0. So we have 15x plus 2y dy dx equals to 0. So dy dx equals to negative 15x over 2y, or you can just leave like this, okay? No. It's, so this is 25. So negative 25x over 1. So we say that is collect. After we collect the x, and then we divide by 2y. So that's why we get this. Okay, the next step, the next example is for y to the power of 4. Sign equals to this. So differentiate y. If y, so we remember that we need to have in y we have x. So if we differentiate y, we get 4y to the power of 3, right? Dy dx minus 4y, 1 minus 1 is equal to 0, so 1 dy dx. So y to the power of 1 minus 1, so equals to y to the power of 0. So y to the power of 0 equals to 1. Okay, so we have this. So 4 to the power of times 1 dy dx. So we have this one. This one is product rules. So product rules, how to deal with product rules? We have u, v. So what is u? U is 3x cubed. 3x cubed. V equals to sine y. So u is 9x squared. V prime equals to cos y dy dx. So v prime u plus v u prime. So we just so u is 3, so minus v prime is cos y dy dx, and then what is u is 3x cubed plus v. Okay, v, what is v? Sin y. U prime is 9x squared. Okay, and then bracket, and then we have 2x, 2 lah. So this is plus 0. And then simplify this, we get Okay, so we have this. Differentiate this, we get 3 dy dx and then 4 dy dx. Okay, this is chain rules. Okay, this is chain rules. See, we have this and this, and then we have this. So simplify this. So make sure this bracket here. So negative 9x squared sin x. Okay, and then this show that we can collect the dy dx. So we collect dy dx, this dy dx, this dy dx, and this dy dx, and then we compile, we get this, and then the rest will be for those not have dy dx. So we move this term in here. So that's why we get this, and then at the end we will get this function dy dx. Make sure dy dx at the end. Okay, so this combine product rules. Maybe combine the quotient rules. So you make sure first is don't just make it easy. Just identify first what should you do. Maybe how to deal with this. Maybe a product rule, maybe a chain rules, maybe a quotient rules. That's only 3 rules that you need to aware. So after you define that rules, and then write it properly, and then collect the dy dx. That's all. So it's quite difficult because we need to deal a lot of things before we can simplify the function. And then make sure your handwriting is very good so that you're not confused with your own handwriting lah. Alright. Okay, and then we have parametric differentiation. Parametric differentiation is almost we have three variable. We have x, we have y. So we have y, we have x, we have t. So what should we do? We can do to differentiate this. We can use a parametric derivative. Parametric derivative meaning we have x to differentiate with respect to t, and then y with respect to t, and then dy dx. Still we need to find dy dx. So how to find dy dx? So dy dx dt equal divide by dx dt. So we dy dt equals to times dt dx. That's all. So t we eliminate, so we left with dy dx. Okay, and make sure that this condition, we have this condition, which is dx dt cannot be 0. If dx dt equals to 0, so this function will be undefined. You cannot deal with. Okay, so now for example, we take this example, or I can take exercise maybe. Okay, I take exercise. We get x. Okay, x dt. Okay, so now we have x and dy y. So dx with respect to dt, differentiate with respect to t. So we have dx dt equals to 1 minus 4 times 3 t, 3 minus 1, so we get 2. And then we have dy differentiate with respect to t. We have dy dt. We got negative cos 2t. This is chain rule. So to make more easier, so u equals to t. So y equals to cos 2t. So u prime equals to 2. So dy dt equals to 2 cos 2t. Yeah, differentiate this, so we get sine, negative sine. So we get negative sine 2. So we get negative sine 2t. So I made mistake here. So we get negative. So dy dt we have 2 negative 2 sine sine 2t. Alright. Okay, and then we know that dy dt. So dy dt equals to, okay, we have dy dt negative 2 sine 2t dx dt multiply with dt dx. So dt dx we need to terbalik kan. What is terbalik kan? Just we make this as a denominator. So what should we have? We will have 1 over 1 minus 12t square. Okay, so now negative. So negative 2, simplify this function, we get negative 2. We get 2, okay, so we get 2, 1, sine 2t, divide by 12t square minus 1, because it is negative. So negative 1, so we get plus here. So this plus. Right, like this. So we get this equation. Right, so the next one is more easier. The next one is just a direct function. So we get this. So dx, okay, dx dt equals to 2 dy dt equals to 2t minus 5. So dy dx equals to 2t minus 5 times 1 over 2. So we get 2t minus 5 over 2. So we get this. Okay. And then we have a tangent and normal line. So what is tangent and normal line? So tangent and normal line like this. Tangent and normal line. So how to get tangent and how to get a normal line? A normal line is meaning we have a line equation, y equals to mx plus c. So c is intersection and m is a gradient. So the gradient of the normal line will be negative 1 over m. And m is a gradient of a tangent line at the same point, at the same point. So for example, if we in general we have this y equals to fx, we have this point, and then we have y equals to mx minus x1 plus y1. And then the equation for the normal line, okay, equation of normal line, dia will be negative, so they are perpendicular. Perpendicular meaning this m will be negative 1 over m. Okay. Okay, for example, if we calculate the tangent and normal line to the function yx square. So yx square when x equals to 1. So what should we do? First is to find m. What is m? So given that x equals to 1 and y square equals to 1, so we get another point. The point of intersection is 1, 1. Okay. Because y equals to x square. And then the gradient, we have y prime. So y prime, that's why dy dx we can is similar to the symbol of y prime. Alright, so y prime, we differentiate y prime, we get y differentiate of x square. So we get y prime, so 2x. So 2x is our gradient. So we put the point here inside here, so we get the value of the gradient. So thus the tangent line is given by, so we have m equals to 2. So the tangent line, for the tangent line, we have the gradient for the tangent line is negative 1 over m. So this is a tangent line. We have m here. A normal line. The gradient for the normal line is ni, like this. Okay. And the rest we just put the number, the point, and then we get the equation of line. So we remember the equation of line y equals to mx plus c. Right. So that's why we get tangent line with this equation, and then normal line with this equation. If we put into the diagram, we have this like this. So we have first function, our function y equals to x squared, and then we get if we differentiate y prime equals to x squared y, so we get 2x. So this is a line. So this is 2x, the function. Okay. And then so y equals to 2x, so if x equals to 0, we cannot like that. We just know the point which is the intersection with the normal line is here. That's why the point, the tangent line consists of the exists from the tangent line. So if we have a curve and we differentiate, so they will get the normal, the tangent and normal line for this point. So if we have like this point, so this something like that. So this we have a normal line, If we have this curve, so that's why it depend on the point that we calculate. So every single every curve here at every point here, they have a different tangent line. Okay, it depend on the point. For example, for this is but if we put the point 0.00, so what we get this tangent line. But if we put negative 1 1, so we will get like this tangent line here. It depend the point that we define. That's the tangent line. Okay, and then we have another question. Find the equation of the tangent line to the point. So we get general point here. So what should we do here? So we get x equals to 3, fx 3. So we get the gradient of normal tangent line is 4. So we just put 4 here, and then the normal for the line. So once we get the tangent line, gradient of tangent line, we will automatically know the normal line. So once we got the normal line, we put the point of intersection here. So we get the equation of line for the normal line.